Hi, Chris.
Testing my microphone. Oh.
I can hear you. Can you hear me?
Yes, I can hear you.
Okay. So we are already on time. I guess we should just start. 3 minutes late already.
Hey, Shane. Hey, Michael. When you're ready with the audio test, please mute yourself. I'm not sure if there's otherwise not too much feedback here in the room. All right. Welcome,
Testing
everybody.
my microphone. Yeah. Okay.
We're here in IETF 120 ANIMA meeting with a very fast switch over from Manet. And I've already showed the note well. Please, if you're not familiar with it, please take note of it. Oops, wait a second. Oh, it didn't upload the latest slide. Wow, okay. Yeah, I'd added one more slide. I'm not sure why it didn't get uploaded here. So if you're in the room, please, you must get into the on-site meeting tool so that you're registered for the room. Otherwise, next time we'll have to do the meeting on the hallway. Then also we have collaborative editing of the notes. So please, you know, if you have something to contribute, whether you're local or remote, please go to the notes page and help edit the notes there. So the active work in the working group has mostly been done on the working group drafts we have slots for, and we just quickly wanted to use the chair slides to summarize the work of the other documents. Since IETF 119, we also had an interim in April 24 to discuss issues reported in those documents, PRM and discovery. And we have a lot of hopefully useful material if you're new to the IETF or ANIMA about our procedures, GitHub, and all the other things in there in the backup of these slides. But due to kind of trying to be conservative with the time, we're not going to go through them here. So what happened in the working group documents without slots? So we have the ANIMA network service auto deployment, which we parked and specifically said we want to give the authors more time to do something. There was a refresh. Haven't seen an update from the authors. Sheng, any updates from your side?
No, we are, because the authors also working on the grasp distribution, we think we should give the priority to it. But for the second item, we are actually waiting the our AD but we heard nothing. So that make us miss the the opportunity to do anything for this cycle.
Yeah, Mahesh is going to the mic.
Mahesh, yes, so this document originally showed up in Rob's queue when he was still the AD, but it does show up on my queue also. I know we haven't quite updated the documents. They don't get automatically updated with the AD role, but I have it in my queue and I will work on it in subsequent.
Thank you.
Good. So, right. So we had then the Brusky Cloud. I remember that when we're reviewing in IETF 119, we had 17 open GitHub issues. Now all the issues are closed, several commits, but no new revisions. So I think the authors are just trying to make sure that everything is in order before they ref it on Data Tracker. Michael, do you want to say something about that? Participant list. Nothing? Okay, so I'll take a note TBD and ask the authors offline.
You're asking me to say something about Brusky Cloud?
Yep. Please.
It doesn't work. I don't think this is working.
Okay. Fine. Let's go on. Let's go on. So we've got RFC 8366 bis, where we're punting the updates from the other documents as far as they impact the Yang model for the voucher. As part of that process, we've been driven from other documents, the INA allocations for the SIT, because we introduce now CBOR encoding of vouchers. That process just went through in the last month. So in the SIT allocation range for that, we removed 8366, which was originally in there, but we're going to start a SIT allocation only from 8366 bis. Because that's also the first one with RFCs pointing to it using CBOR. And then we had various fixes and examples. So then there was good ongoing work on the constraint voucher. A lot of GitHub issues closed, 7 left, mostly editorial. And as a shepherd, I'll do another review round shortly. And then the document that's mostly in the waiting pattern since last year because of constraint voucher is the follow-on to that, which is the constraint join proxy. And so we'll get to that when we're finished with the constraint voucher as authors and shepherd. Okay, so that is what we had for the non-slotted working group documents. So on the agenda now we have update on Brusky AE from Stefan. Do you want to share the slides yourself? Yep.
I just asked for the slides.
Yep. I think it's just, and there we go. So you should be able to do that.
I don't see something on my side. So I request it again. There it is.
There is.
Okay. Yeah, just a short update on Brusky AE for alternative enrollment protocols in Brusky. So we had some comments from Mahesh, which we got in May, back in May. So that was the AD review from him. So we handled the comments. Most of them were editorial and nits that got addressed. We also did the Gen Art review just shortly before the IETF cutoff meeting in June. Also there, we just handled some nits, and basically we are now at revision 12. So here we put a list of specific items that we changed in the draft based on the AD review by Mahesh. Most of them, as you see, are editorial. The only thing that is a functional change is that we changed the TLS channel reuse by the enrollment protocol from recommended to mandatory to basically use the established TLS channel that is already there from the voucher request response exchange, and not giving the idea that we would like to build up a new transport connection between the pledge and the registrar. So that was the only functional change in the document. And then also the nits from the Gen Art review have been fixed. So thank you very much for all the reviews. And so based on that, working group last call is done. Young Doctors review is already, the pre-review is ready. All the different reviews that you see here are ready. So the current state is waiting for AD go ahead. And based on the latest update, the next step we see is IESG evolution. Any comments?
So just your cue, Mahesh, I think.
Mahesh, and I did put a comment on the whatever the chat tab in Meet Echo. So I do acknowledge that I did see the changes, and thanks for getting them together. I think, yes, we should be ready to, I do need to make one more pass just to make sure that everything is in order before I press the button to send it to IC.
Okay, thank you. That sounds great. Okay, so then I would ask again for slides and doing the next round with JWS voucher. Okay, so this is the update on JWS signed vouchers. So just to have a short recap on that. So RFC 8366 and also RFC 8366 BIS, they both specify CMS signed voucher, CMS signed JSON for voucher artifacts. What the draft does is it specifies JWS signed JSON for the voucher artifacts. So it's a very short document. It makes no changes to the 8366 as such. And the approach or the encoding that is described there is already being used in Brewski PRM, which I will give the next update then. So from a status perspective, it was in working group last call before IETF 116. We had the Shepard write-up by Matthias Kovac back in July last year already, and then we for whatever reason that somehow slipped our fingers, the individual comments from Mahesh that were addressed in the last version that we got from in June. So they basically related to some clarifications in the document scope and also some editorial improvements. So what is open or to do here is a YANA registration of the type value definition for application voucher JWS JSON. And then the document as is ready for the official AD review by Mahesh, besides his individual comments that we already incorporated. And yeah, as always, we are interested in interop testing with others, most likely in the context of Brewski PRM. So that's a short update on JWS voucher.
So did I hear something like we should do an IANA early allocation or to help support the interop testing, or can this wait with the normal process when it?
It could wait for the normal process.
Thanks.
Okay, so if there are no further questions, then I would jump over to Brewski PRM. Having 3 in a row is kind of fun. Okay, so this is the update on Brewski PRM, so pledge in responder mode. Meanwhile, the draft is in version 14. Yep, so we had an interim ANIMA working group meeting, and we used that time in the meeting to have some clarifications of the CDDL usage when there is no young definition available for the objects that we use in the different prototypes and functions. So that was being discussed with Carsten Bormann and incorporated accordingly for all the different CDDL examples that are in the document. What we did afterwards was an update of the examples that we have in the annex. So the pledge voucher request, the registrar voucher request, and also the voucher to match the definitions that we have in the draft to allow testers to better test their implementations. We added some clarification for cases when the clock itself has no synchronized clock, how to handle the triggered voucher request and also the triggered enrollment request, that there is not the same time, but that the time is being advanced from the trigger, from the first trigger message received. So that's being added to the draft. And we also added in the registrar voucher request, for whatever reason, we missed to include in the description the IDFID issuer field as it is described in RFC 8995. So that was, at least in one of the figures, it was missing and it was inserted there. So then afterwards, that resulted in version 13, and then yeah, we did the final review or the final round of review from the Shepherd. So Matthias did, I think, starting from section 6 point something to the end of the document, and the document has changed from yeah, not from the functional point of view, but from the structure. So it should be much better readable now. Specifically, section 7 has been restructured to describe the protocol flow, always using an overview description, the request artifact, the response artifact, and also the return values. So that should read much easier now compared to the description before. What we included based on the Shepherd review was a new section 6.4 that explains the necessary steps that are to be done or to be enhanced on the MASA side. We had that included for the pledge and also for the registrar, and we had it implicitly stated throughout the text what is the expectation of the MASA, and we put an own section now in as we have it for the registrar and also for the pledge. Then also based on the Shepherd review, we had an alignment of the pledge status response data. So that is specifically being done to rely on the same type of structure that we have in Brewski. So that means for the voucher status and the enrollment status, we are using the same approach and the same semantics. And we added a new exchange for the pledge status where the registrar agent is able to query in which status the pledge currently is. And for that, we also changed the utilized data objects to the ones that are used for the other status messages. The only difference to Brewski is that there is in Brewski, the reason code is included as optional field. For Brewski PRM, we require it as mandatory. Last but not least, we included a new section on logging hints. That's section 8. That's basically to give some recommendations which of the events, when there are error cases, should be logged for auditing. So that's an informational section, but we felt that it is good to have it in. Yeah, so far for the changes. Then based on the Shepherd review, we have some food for thought, let's call it that way. One of the discussions we had with the Shepherd was we currently have, for the communication between the registrar agent and the pledge, we rely on HTTP. because the objects that we exchange are self-contained, so there are signed objects, and there is no real need for a transport layer security underneath that connection. It is recommended, or it is provided as optional TLS connection in the draft to ensure privacy of the connection between the registrar agent and the pledge. So for the case when for that one, we have a whole annex that describes the boundary condition and what has to be obeyed when using TLS between the connection of the registrar agent and the pledge, because the IDEF ID certificate that is used on the pledge side doesn't really can't really be used in the context of a TLS connection because it doesn't contain a subject alternative name and the DNS name. So for that, the draft already defined to utilize the X520 serial number, and that the registrar agent shall be able to verify the serial number that is contained in the certificate when opening the TLS connection towards the pledge. What we discussed with the Shepherd was one proposal to think about using a local name in the IDEF ID certificate, because the pledge is discoverable via MDNS. So if the pledge provides his local name via MDNS, which could be something like vendor identifier, pledge serial number .local, then the registrar agent would be able to verify the DNS, so the MDNS or the local name, which is contained then in the IDEF ID certificate in the subject alternative field. And that would enable the registrar agent to essentially utilize a state-of-the-art TLS implementation to verify the server-side authentication of the pledge. So we thought about that, and I also did some search through the CAP CA browser forum requirements. So that one specifically doesn't allow internal names and the DNS name of the subject alternative field or component of the server-side certificate. But in that case, we use it here. It's not being used for browser-based access, but for registrar agent-based access. So it's not necessarily a browser. And we basically thought that we take that question and bring it to the working group to gather some input on that proposal. We know that if you use the local name in the DNS name of the subject alternative names, then this is something where we lose the verification part over a DNS server. That is clear. But compared to checking the X520 serial number, it's essentially the same approach. The pledge delivers both the X520 serial number as well as the IDEF ID certificate. The same would be true for the local name in the IDEF ID certificate. Any thoughts on that?
Mahesh, again, if you could go back, I think one slide. Yeah, on the last item, which is the logging section. I just took a brief look at that section, and I don't know whether Busky has a format much like syslog does in most systems, where you have different levels of logging information. So what I saw was mostly info level information. Are you saying that there are no errors or other level of messages that could be possibly logged?
There could be further messages logged. That is true. So we didn't use something like the severity field from syslog to describe it in that annex. So it was just to give an idea what we would expect for the audit trail to be logged. Okay, then I would propose regarding the .local, if there are no comments, then it would probably be good if we discuss that in the design team meetings or on the list, and I can basically refer to that discussion then.
I'll read the diff before Tuesday, so I hope
Okay.
we have more
So
of the
we haven't included, regarding the .local, we haven't included anything in the draft because the draft also works without that, but this is something to simplify access to a pledge, and that's the reason that I just put in here food for thought, so there is nothing included in the draft so far. Okay, so then we have a second thing which came out of the discussion in the ANIMA design team meetings. So currently Brewski and all of the different variants like AE or PRM, they handle the provisioning of a generic LFID certificate. So that one can be used to manage further LFID certificates in the operational phase, like application-specific LFID certificates or others. It can also handle situations where there's a handover between different domains, for instance, during installation and commissioning. So in general, as Brewski focuses on the establishment of one generic LFID certificate, the intention was to utilize re-enrollment options for the protocols that are used for enrollment, and the same endpoints on the registrar to basically enroll for additional certificates. So this is something which is, from a functional perspective, available via those enrollment endpoints that are available on the registrar. And it's not something which is specific to Brewski PRM. So what we discussed was the idea to put that as an enhancement in the operational considerations for the Brewski register to cover the case where more than just one certificate is being used during, or shall be established during the onboarding time. Any thoughts on that item?
No, I was in this talk about the TPM, but it didn't seem as if what I was trying to figure out what even if there is a good namespace to distinguish different key pairs and in result LDIF's IDs. So that's what I'm a little bit worried about. That we've been talking about how we identify those in the team calls, and I haven't found a good evidence in the IETF yet for any namespace for that to exist. So that's one thing we can continue to dig in other working groups.
Mm-hmm. Okay. So then I'm jumping to the last slide. So based on the current discussion and the status, we don't have any open issues. We had the working group last call before IETF 116. We had IoT and SecDir early reviews and also young doctors early review. Meanwhile, the young doctors early review is not necessary really, because all of the young parts of PRM have been moved to 8366 bis. So there is no young included anymore. Shepherd review and also the write-up has been done this week or finalized this week. So based on that, we think that the document is ready for AD review.
Mahesh, so I know you said the working group last call was done before 116.
Yep.
Did any of the reviews result in any changes that you feel maybe another short last call may be warranted? This is more a question for the chairs.
Yeah.
So I'll take it as an AI between Sheng and I to check the differences and see if another last call is justified.
Okay.
If you do the check, do me a favor, keep in mind that the whole structure of the document has changed, not necessarily the functional aspects. Okay.
No, I understand that. That's the pain for us, that we need to distinguish between really functional changes and textual changes. The improvement in the textual changes themselves, I don't think would qualify for last call. So that's...
Yeah. Right. I forgot to ask one question for during JWS voucher. So the question is, right now the status is AD review, but that review is assigned to Rob. And I'm not quite sure if that it is also meanwhile in the list of Mahesh to do that official AD review.
Mahesh, I think I just now updated the data tracker. Maybe I did it for the other document, grasp, but I'll also make sure, as I clarified up in the beginning of the meeting, that some of this is just hangover from the previous 80. Don't worry too much about it. It is on my queue, so I do see it, and I will work on the document.
Thank you very much. Okay, then I'm done.
Thank you. So yeah, it is in. Okay. Yep. Thank you. Okay. So this is the update on the Brusky discovery draft, which we adopted shortly after last IETF, and which originated from pretty much outsourcing a lot of various discovery text from different Brusky extension drafts into this document to create a consistent and extensible, flexible solution for that beyond what the drafts themselves will maintain, which is for each of them pretty much one minimum MTI version. So I quickly wanted to go through what we had done here. So there was a lot of editorial work done. We had in the intermediate meeting, we worked on finalizing the way on how to encode this in the core link format, which is one of the three discovery mechanisms that we are planning to support from the beginning on. Updated the document accordingly, and I'm going to do one more run through the text, trying to simplify it, maybe move a lot more of the explanation or so to the appendix, that the main normative part of the document doesn't look as big as it is right now, but I feel the explanations are very important, and would like to get to the state of asking for working group last call in or before Dublin. So I've been trying to summarize a lot of the stuff so that the slides also are a good way to get started understanding this, because I would really love for more reviews to happen for the document. I'm not going to talk in detail about everything that's in the slide. So one of the important parts is really that we're having this concept of the proxies. And when we do have different ways of registrars and pledges to be compatible or incompatible with each other, we don't want to create more complexity by the proxies also doing there. So one of the things that the discovery does is to make sure that they're fully transparent and can pass on the information which registrar ultimately can be used by which pledge. And I think that will help very much to make the different variations that we may need to support painless. So the outcomes of oh, this is not nicely formatted. I apologize. So in the core link format, what we concluded on is the new names for the route targets, which is kind of the service name in Core LF. Brusky joint proxy, Brusky RS for registrar stateful, and then Brusky RJPY for the stateless proxy, which is new, which we didn't have in before in 8995, because we didn't have the stateless message format, because that requires UDP, and that of course came with constraint Brusky. So as far as the way the document is trying to work, is ultimately it's meant to establish registries in which all the information can be put, so that we don't need to write for any extensions of discovery mechanisms, new updates to existing documents, create potential problems, but make that very easy. And so the first thing is really describing the different contexts of discovery that we're interested in, and what we're calling Brusky is really the discovery of registrars by pledges, potentially through proxies, which we have from 8995. And so what the registry is then going to do is to define authoritatively from here on out the service names used in the different protocols, like shown here for GRASP, the good old AN join registrar, AN proxy. So those things that we had already defined, but now it becomes extensible when we want to add more. Same thing, DNS-SD. Then CBRUSKI, constraint BRUSKI. We're going to have 3 discovery mechanisms of interest from the beginning. The core mechanisms I was just talking about, DNS-SD and GRASP as well, depending on deployment environments that refer to the different ones. In BRUSKI PRM, we also may want to be discovering the pledges. That's another context, so that's agents discovering pledges. So the context is the registry that defines really, different discovery mechanisms to consistently discover one type of service in BRUSKI by some other entity. So then comes within a BRUSKI connection, we have identified different aspects where there can be incompatibilities, right? So on one thing, it's the whole endpoints that we're selecting. So far we've identified that the normal way 8995 works, the registrar responder mode, and then the PRM pledge responder mode. And, a registrar may support both or only one of them. We have different formats for the voucher. We have the CMS encoding, we have the COSE encoding when we use CBOR, and we have the HOSE encoding in BRUSKI PRM. So those are all choices of different implementer communities. And we have potentially different enrollment protocols, EST 7030 RFC, and CMP, which is preferred by BRUSKI AE deployment types. And then for reservation, just to show that there's a lot more, we're going to reverse SEP, but we know there are others as well. And now comes this tricky things. How do we do that in the discovery mechanisms? So variation is really just a list of one value for each of the variation types, right? So BRUSKI would be described as its RRM plus CMS plus EST. And to make that extensible, all this information is going to be in a registry. And this is this second registry part, which defines the different variations type, mode, view format. This is just an excerpt, right? It's not the full initial registry. Then the variation types, of course, the references, and then also whether it's the default or not. And then ultimately we get to the point, how do we encode it in the different mechanisms? And so when we came from pledges, very small footprint, very difficult to diagnose software, we said we're going to encode a full variation as a single string, so that the only thing we need to deal with in discovery is a list of possible string, each of which defines a variation. So the final and third part of our registry is going to be this list of variation strings, where we now have EST-TLS or empty string for 8995, CMP for BRUSKI AE, PRM HOSE for BRUSKI PRM, and then empty or RRM HOSE for constraint voucher. There are a lot of variations we can do, but the whole point is we're only going to add them to the registry when we have somebody asking for it, so that we don't unnecessarily fill up the registry with things that nobody at this point in time wanted to implement. It's going to be specification required, so that way we can easily track when people want to start using variations. So that's pretty much the concept. I don't want to spend more time in showing the example encodings. It's very easy to make all these encodings wrong. There are a lot of crazy details not related to the variations, but I hope that the document will help, implementers that do the discovery to make them better. And so the red stuff is showing for the 3 different versions examples on how this is being done and explain the tricky parts.
Mahesh, I think, yeah, if you could go back to 1 or 2 slides to the IANA, the registry, the third, I think, yeah, that one.
Mm-hmm.
So did I get it right that currently there is no registry, at least the entry for 8995?
That is the first line. 8995 is the first line, and depending on which protocol we have. There is a note down here. It's either an empty string. Some of the discovery mechanisms will not support an empty string, so then it's EST TLS. So that's just defining exactly that variation 8995.
And this is there today in the ANA registry.
No, this is basically, this registry this is the main output of the document. It is creating this registry.
Okay, so, okay, that was part of my question. So currently you're saying 8995 has no registry definition and this doesn't exist.
Exactly.
So someone who is going to go to 8995 only will not know.
Will exactly find EST in GRASP, but it wouldn't find a really good information about DNS-SD, or if we wanted to, if somebody wants to do 8995 in an environment where the core discovery mechanism is, he wouldn't know exactly how to do it, but he could basically just, ask for this to be added with core LF. So basically now these things just have to be done by extending the registry.
Yeah, I don't know from a process perspective what we can do to go back and have.
It's fully backward compatible, right? So we
I understand. I'm just thinking from a for somebody who's implementing does not know about the any of the registry entries is what I was thinking of. But maybe it's not an issue.
No,
it's something.
No, it's all meant for forward compatibility, because we've seen when we started to do the different variations here, Brewski PRM, Brewski AE, constraint or so, that we had to rewrite all the discovery text and maybe just the subsets needed for that. And then we always felt, what is another implementer community, another type of IoT network wants to use one particular mechanism, but with a different discovery. We've seen that particularly between, let's say, the IETF who prefers core LF, and then, for example, the thread group who prefers DNS-SD, right?
Okay.
So then basically, if we just have the IETF solution, they can badly adopt it, but with this registry, that makes it, for example, easier then.
Okay, maybe then the only other question is this document does update 8995.
I think, yeah, so I mean, that's basically for us, when we're through last call with the ISG review, it's not any backward compatibility, it's extending it. So you tell me if an extension is an update or not. So that's.
Yeah, I'm just thinking from one way to kind of catch the fact that when somebody looks at 8995, they will see that there's an update.
I like the forward pointer. I'm not sure if that's common practice in the IETF. So there is no backward incompatibility or something. So yeah, you tell me.
I think it would be a good idea to at least mention that it does update 8995.
Yeah. Okay. All right. So that was it. Please review. I'm all for bartering, right? If you have something to review, I'm happy to do that as well. So you're up, Michael.
Is it working? Does it work?
Yes.
Yeah.
Yes. Okay. I was worried. Can you put my slides up and give me control?
So I should, give you control. I haven't done that. Let me see. Stop
You
slides.
click on my name on the participants and you pass control.
There we go. Okay. ACP implementation report. Confirm your selection. And then user management.
Click on my name in the participants.
Pass slide control. There we go.
Thank you. Okay. Good. Okay, hi, I'm Michael Richardson here. Had a rough night. I'm staying in my room to keep you all away from my gastric bug. And I'm going to talk about my implementation of really it's 8994, but of course it has a bunch of other bits in it. Who is list? There's a bunch of different components in my system, and I'm talking most about the ones on the right-hand side today. Many of you have used the components on the right and the left-hand side. It's called Animagus. If you're a Harry Potter fan, you'll know an Animagus is a person who can change into an animal. So it starts with Anima. And you may also know that Professor Minerva McGonagall is one of the characters that can change into a cat. And the goddess Minerva is also the goddess of things. So that's the nomenclature for you. Okay, so this is a rough architecture diagram. I've tried to come up with a good way to explain it. Brian Carpenter asked me, why am I using Penrose diagrams that would otherwise describe black hole spacetimes? And he's absolutely right. They do look like that, but they're not. They're just boxes. So there you go. So there's three different pieces here, and they use Linux networks namespaces, which is a component of how it implements containers, but it doesn't use all the other pieces. So it doesn't, for instance, separate the file systems or the process IDs or the user IDs. It could, but it's not. It wasn't necessary to do that. So there's this one namespace, which originally I was calling the dull namespace, and I realized that was kind of very specific to GRASP. So I'm now calling it the abutment namespace because it's connected. It abuts the other piece. Then there's an ACP namespace. And finally, there's a system namespace. And the key thing you need to understand about network namespaces is that each have their own forwarding table, set a list of interfaces, neighbor cache entries, and all that kind of stuff. So they're effectively different systems, but you can in fact build interfaces. For instance, you can build Ethernet pairs that, or you can put one in one namespace and the other in the other namespace, and then you can have traffic between them for that. So on the bottom, you see this one called ACP0. So you should imagine that is an interface that the system sees, and it's got a /48 route into the rest of the ACP, so the ULA that the ACP would be running on. So a little bit more about how it works. There's a main system. It creates this abutment namespace using an unshare system call, and then it actually has to start the thread and event-based runtime because you can't spread that across processes. It establishes some IPC to be able to communicate options and other things about that. It creates an ACP namespace, similar kind of concept. Runtime starts and another IPC. And then essentially then it starts scanning the interfaces, looks for available interfaces. When it discovers one that's new, it makes a pair, pushes that interface into the abutment thing, and that's how you actually get the abutment connected to a physical interface. And then when things are detected and tunnels are created, then the system creates this X-form tunnel and it sends it into the ACP namespace. And that's where the ripple daemon can then see the other ends of the tunnel. So what it looks like with you have two of them. There's two test systems. Mine are named Moira and Ovid, and they're related in a complicated way to Greek mythology that doesn't really matter. This guy does an M flood. This guy says, oh, I see you there, and I'm going to do an IPsec Ike with you. And let's see how that works. And it's going to create an ACP interface to represent that tunnel that it's bringing up. So then you get an ESP tunnel between the two abutment namespaces. However, the packets that come out of that tunnel are sent to this ACP interface in the other namespace. So the outside of the tunnel is in the abutment namespace, and the inside of the tunnel is in the ACP namespace, which is essentially exactly what we want to have happen. And then the ripple daemon says, oh, look, there's a new interface. It's up, and it's going to send some messages on it, ripple DIOs and DAOs, DODAG information object and DODAG advertisement object. That's the kind of back and forth. And you establish a mesh on top of it. So a little bit about it. There's a daemon called, what I've just described is a daemon called Connect, written in Rust, started in 2020. It's about 55,000 lines of code. It uses a fork of OpenSwan, which was known as FreeSwan and LibreSwan, and a very long time ago, StrongSwan forked from it. So that's going back 25 years ago for that. I just made a fork because I didn't feel like arguing about what, and I don't want any IQ1 code or stuff like that messing things up. And then I have a RIPL daemon called Unstrung, which was written in C++ around 2009 there. And I thought it was, I think I'm probably the only person that's written all 3 daemons and has all that technology in somewhere in my head at this point. There's lots of interesting challenges along the way. One of them was that it turns out that if you let your namespace kind of die on its own with systemd, then it gets really confused and kills things, and you have to reboot your system. So that seems like a real bug, and I don't have time to pursue it there. And then the major problem was that ESP packets don't have a way to connect them to the right interface. So while you can put IPv6 link local addresses on the outside, it turns out that you can't scope them to the right interface, and packets go to the wrong interfaces. And this was hidden a little bit because some of the earlier technologies caused other problems. So for instance, you create a tunnel from A to B, and it would capture all the ICMP neighbor discovery messages. That means that you can't discover B, and then things don't work if you do it in the wrong order. But the lack of v6 link local address was obvious in hindsight. I'm like, oh, why didn't I notice that? But there. So the obvious thing was to, well, we should modify the kernel to put scope IDs for this. And that was something I kept thinking it's a good idea. And many people, a couple of people in the group were like, yeah, how do we get it done? And then someone said last fall, well, could we just do this with ULAs instead? And I was like, I didn't want to do that because I wanted to fix it properly. And then I said, okay, well, let's just try it. Let's just go forward and try it. And the other reason to try it is that I'd like to be able to run this code on what might be slightly older switching platforms and routing equipment that have Linux kernels, for which we might never get be able to patch the kernel properly. So each system numbers its interfaces using a different ULA than the ACP ULA. And let's say it's FDAB 1 2 3 4 5 6 3 4 5 6, and then the next to the subnet ID, I just made it be the IF index number, which is at least unique within each namespace. And then the lower 64 bits come from the interface identifier anyway for that. And I'm trying to go faster here. So the grasp changes slightly. There's this announcement of, instead of link local address down in the protocol description, it's a ULA. I've left the initiator to be the IPv6 link local address. I think that works well. And one of the things that you need to do, so these are 128-bit ULAs, and it's interesting, if you were in the room earlier, Fred talked about multi-link addresses, and actually we could use those too. And this is the demonstration really of using ULAs in that same kind of way, if there's someone still in the room left over from Manet. So to make it work, you have to put a route in. So there's a route you see, the 128 is implicit there, and it goes via a v6 link local address with an interface identifier, in which case it's called dull, because I remember I was calling them dull 14, and that's related to a number. So it's a unique name. And so you wind up with one in each direction going, or one for each connection that you're going to have. That's really no different than a neighbor cache entry, the same thing. So one of the things I learned in developing this is that, so Linux has these things called Mac VLANs. A number of other platforms have this, and basically it's a second Ethernet address, the same physical hardware underneath. And that's wonderful, and it works great, except that if you have an interface that is also part of a bridge, then it uses the two mechanisms use the same internal hooks. So you can't have an interface that's both part of a bridge and has a Mac VLAN. And so it does the right thing for that. But because these interfaces are made up, they get randomized Ethernet addresses, which makes their v6 link local addresses unpredictable, which is kind of annoying because you can't hit up arrow return to resume your debugging. You have to go and read what's going on, and you have to send the right thing to the right place. Oops. One of the other things that was really annoying is that each one of these ACP interfaces that it puts into the ACP namespace, originally I was calling it ACP 001, 2, 3, 4, whatever, whatever. And I'm like, oh, I can't sort which one is which. So in the end, I gave them a name, which is the lower 4 digits of the um, uh, address, of the link local address that connects them to. So this is now an EULA, but it's still the lower 4 bytes, and I sorted them in the way so they're consistent across the two or 3 systems that you see here. And this is, 3 systems that have a triangle mesh between them. So that made that just like the number of times where you go to debug it, it doesn't work, but it turns out you're just doing the debugging wrong. That reduced it by 10 times. Like, okay, I'm actually testing this properly, and you can see there's an ESP packet in that gray box down there that's going from those 2 addresses. So 8D44 to 3E6B. There's an ESP. It has a SPI number and a sequence number, and some of that stuff works. What doesn't work, however, is still there's some issues with keying, where if both ends key at the same time, the duplicate keying detection doesn't always work, and one end deletes the wrong IPsec SA. This is a bug. End result is that there's a timing dependency, and when it doesn't work, you get this very difficulty bug thing from the ACP. In my testing, I have typically 3 machines because that's the kind of minimum that's interesting. When you put them on a LAN, you get the kind of picture on the left where they both kind of connect to that, and because of the way Ripple works, they both wind up being direct children of the other node. The more interesting thing is you put them in a series, which means creating a unique LAN for between each one, so that you'll actually get a deeper stack and a more interesting thing. And that green machine Wara still has to have 2 connections to the 2 places. So one of the problems is if we keep the ULA, that's probably going to need a short draft to amend 8994 that says do this. I'm really, really hesitant to say do this because it's a hack that I think will just never go away. We can announce both the original, and this mechanism in Grass, but of course, if a node doesn't support doing ESP over link local v6 addresses, then it shouldn't announce that. And so I don't know what the right answer is. I would like to have it work on sort of every kernel out there, but I would also like to have it work properly. There's a lot of the debugging is seriously tedious. As I say, you get a lot of random numbers from things, and it's hard to know what it is, what's what. And it would be nice to get a picture or a diagram, enough data to get a picture or diagram back as what's going on. And that would be nice if we could have, Yang modules or something that really turns that into something to draw a pretty picture. That would be lovely. And finally, one of the concerns I have ongoing is, what if you have a lot of machines? So you have a cabinet full of servers connected to a top of rack switch, which does not speak ACP, then, you're going to get a lot of potential tunnels connected because you've got a full mesh potentially that would occur. We don't need a full mesh. We need, 2 or 3 connections, but you don't, Ripple doesn't get to prune the connections until after the tunnels are up. So that's a lot of tunnels that we're creating for potentially no purpose. And so Grasp probably has to say something about that. And there's different ways we could do this, and I don't know the right way. But we did do something equivalent to 9032 for 6-tish, and we could repeat the same kind of thing. And that would be such a lovely problem to have, wouldn't it? I'm done.
Thank you very much. I'd like to comment on that link local stuff because it just occurred to me that we're not the only victims. But for those folks who've been following 6man, and there's also HTTP BIS, there's been for years the ongoing struggle for support of link local addresses in browsers, which kind of led to now maybe even retiring more of the basic link local support in URI encoding. So it's a really pain that link local addresses are the correct way to do things, but they're hard and they haven't been used much. So a lot of the industry hasn't and doesn't want to adopt them correctly. So we're perfectly on the right track with the rest of the IETF to try to find a workaround, unfortunately. But so I like what you've done very much, and I'm just wondering if we can find a way to use these some addresses which are not heuristically clashing, that are global, and we're using them locally. So I'm be thinking about that. And I think as an outcome, what we would have be beyond maybe these type of implementation considerations to document them is, as you said, some potential extension that we're really standardizing for GRASP DAO to allow the use of such addresses, right? Which is either a hack, or if we can get it work without random collisions, then I think it's not even a hack. It's just a recognition that the linked local addresses are difficult. Okay, anybody else? No. So we had one extra non-working group related presentation. Sheng, what's your opinion on going over, or do we want to try to move it to either Dublin or an interim? What's your preference?
If we could go over time, we would like to do the implementation. That's done by Norway, maybe 5 minutes.
Oh, okay, that's fine. It's not working group, so from it's, yeah. Please go ahead then.
Your arm. Oops.
Yes. Uh,
No,
I'm
your
sorry, I
slides.
can. I
Share your slides
can
again.
you give me the control? I can see the slide in my screen.
Terrace?
Yeah, let me try to see that I bring up the slides and pass on.
Mm.
Okay, be quick.
Uh, I will introduce the lightweight grasp proposed by me and Shen. Uh, with the rapid development, the IoT is urgent for self-management. The animal grasp has great potential for self-management. But however, it is not an ideal choice for the IoT. The main reason is that the grasp is built on TCP/IP and relies on the reliable transport services provided by TCP. But the TCP and IP is not a good choice for the resource-constrained devices in the IoT. First, both the TCP and IP are heavy. Second, the additional latency, control overhead, and memory consumption caused by TCP are inevitable. In addition, the TCP performs badly in the weak network environment. Thus, we have proposed the lightweight grasp, which is UDP based. Mm, there was two main changes for lightweight grasp over grasp. The first is that we have shortened the fixed fields. In details, the length of session ID is changing from 32 bits to the 16 bits. Mm, and the objective identifier is changing from the text string to the uh, uh, with indefinite length to the 8-bit objective number. The second is that we have introduced a message-oriented built-in reliability mechanism, which enables the lightweight to work reliably over UDP. With the 16-bit number that is announced attached to the message, the lightweight message can be acknowledged and retransmitted if timeout. For this, an act message and two options are newly defined. In the a lightweight grasp. All the unicast message must be acknowledged, and so they must carry a rec arc option and can carry zero or more arc options, while the multicast messages are not necessary to be acknowledged, and they are not allowed to carry the either of the both new questions, new options. In addition, we also discussed the possible IP independent method, since the IP connections are not always supported by the resources constraint node in the IoT. The core is to select and define a new locator option and a new protocol identifier. Uh, and an example how to exchange lightweight grasp over Bluetooth low energy is given in the draft. Mm, Before this meeting, we have received some comments from Brian with regard to his suggestion. In the future, we intend to add a mechanism on the recipient side to detect possible duplication caused by lost acknowledgement, and we like to pay more attention to the negative acknowledgement and more security issues concerning chemistry node and their possible solutions. Mm, uh, is there any comments or questions? And we want to know is the animal interested this work? I'm done.
Yeah, we really encourage people to read this new draft. And in last IETF, I did giving very short introduction without the draft. Now we already submit the draft, and we hope people could read and give us comments. More importantly, we would like to hear from the working group whether there's interesting work to adopt by the working group in the future, and also whether it's in the milestone of ANIMA working group. Thanks.
All right. Closing words. Thank you very much, everybody. Please read, comment, review the working group documents and the other documents you're interested in, and use the mailing list. And else, see you back in Dublin.
Thank you all. See you in Dublin.
Thank you. Bye-bye.
I have the well. How you doing?
Yeah, fine. Good to hear. That's a quiet group.
Well, it doesn't help for Michael to be in his hotel room and Sheng not having gotten a visa in time, and most of the European folks being on vacation and just